Hi students, today we are going to discuss about one component water system. So we are going to take an example of water system. We know already water exists in three different phases, namely solid, liquid and vapor. So here the equilibrium can be graphically related as liquid vapor equilibrium, solid liquid equilibrium, solid liquid equilibrium, metastable equilibrium and triple point. So we'll discuss one by one. First we will take curve OA. So this is called as vapor pressure curve. Here equilibrium exists between liquid water and water vapor. So by applying a phase rule, F is equal to C minus P plus 2. Here it is a one component system and we can able to see two different phases here. One is liquid phase and the other one is vapor phase plus 2. So F is equal to 1. So it is a univariant system. Next, we'll discuss curve OB. This is a sublimation curve. So sublimation is nothing but the transformation of solid to vapor. So here there is an equilibrium between solid ice and a vapor. So by applying a phase rule, F is equal to C minus P plus 2, F is equal to 1. So this is also univariant. The curve OB extends up to minus 273 degrees Celsius. Beyond this temperature only ice present and no vapor. The next is curve OC. This is called as melting curve of ice. So melting is a process, the conversion of solid to liquid. So here the equilibrium exists between solid ice and a vapor. By applying a phase rule, F is equal to C minus P plus 2, F is equal to 1. So it is also univariant. When you increase the pressure, the melting point of ice decreases. Next is the metastable equilibrium. It is shown in the dashed lines OB dash. OB dash curve is extended curve for the vapor pressure curve OA. It is called a supercooled vapor. Sometimes water can be cooled below 0 degrees Celsius without the formation of ice. It is called a supercooled water. It is unstable and it is connected into a solid by give a slight disturbance. Next is a triple point O, where the three curves OA, OB, OC meet at this point. Here three phases are simultaneously in equilibrium. This is called triple point. In this triple point you can able to see three different phases: solid ice, liquid water and water vapor. By applying a phase rule, F is equal to C minus P plus 2, F is equal to, the component is only 1 and you can able to see three different phases plus 2. So F is equal to 0. It is non-variant. Next, coming to the areas AOC, you can able to see only water, and BOC you can able to see solid ice, and AOB you can able to see only water vapor. So if you calculate the degree of freedom, F is equal to C minus P plus 2. So here component 1, phase 1 and 2. So F is equal to 2. It is bivariant. So at the end of this lecture, you can have knowledge on one component water system, areas, curves and triple points present in it. Thank you.